Welcome, guys, once again to the best math channel in the world. So, your busy made it easy channel. The only channel exam fears when it comes to mathematics. If today is your first time seeing us, don't forget to hit the subscribe, like, then you comment. Today is the fourth lesson on our coordinate geometry. And today we are going to learn about application to triangles using the coordinate geometry. Application to triangles using the coordinate geometry. We are going to determine the type of triangle using the distance formula. The type of triangle using the distance formula. The type of triangle using the distance formula. Now, this is what you need to understand. So, when 3 points are given to you to determine the type of triangle, let's say we have M, N, and O. Using and you know the distance formula. Yes, the distance formula we have done in my first video. The distance formula to find the magnitude. That's the square root. We know is the square root of the x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula. And since we use two coordinates, and this is a triangle, so we can pair MN. We can pair MO. Then we can pair NO. They are coordinates. Yes, so we are going to find each of these. And one thing you have to understand is that if all the points or all the three sides are equal, we are going to determine the type of triangle. So the type of triangle, we have the equilateral, we have the isosceles, we have the scalene, then we have the right angle triangle. So we have the right angle triangle. So when you calculate and all the sizes are equal, it is an equilateral. Equilateral, all the three sizes and angles are equal. If only two sizes are equal, then it means it is what? An isosceles. Yes, it is an isosceles. So the type of triangle, equilateral has all three sides and angles being equal. Isosceles has only two sides and angles being equal. And scalene has different sizes. It has unequal sizes and angles. That's what you need to understand about scalene. And if one side of it, yes, if one side of it or the three sides also forms Pythagoras triple, then it means this is a right angle triangle. We are going to take question on all of that. We are going to understand what I'm trying to say. So when a given coordinate has been provided for you to determine the type of triangle using the distance formula, your answers will determine whether it is equilateral, isosceles, scalene, or right angle triangle. This is further mathematics, and we are going to simplify it on this channel. So we are not going to waste time here. So you use the distance formula. That's what you need to understand. That's why you don't need to forget your formulas. So to determine the type of triangle, I've done that, how to find the distance of coordinate. Yes, the distance or the magnitude, if you understand. So if you remember the formula, just quote it, then you solve it. So I've told you when the 3 points are given, you pair them. This is a triangle, MNO. We have M and O. So we can take these two, then you take these two, finish. Because MN is the same as NM. MO is the same as OM. Then MO is the same as OM. So that's what you need to understand. So let's take our first question on this. So the first question said triangle ABC has the point 3, 5, 7, 2, and 3, -1 respectively. What type of triangle is ABC? What type of triangle is ABC? So they say triangle ABC. So the points are given respectively, and respectively means the first point for the first number, or the first name for the first number, the second for the second, and third for the third. So we are going to determine the type of triangle. So since it is ABC, so our A is the 3, 5. Our B 7, 2, and our C is 3, -1. Yes, and I've told you we can pair the AB, AC, and BC. Finished. Yes, AB, AC, and BC. Finished. So 3 points. Now let's go. So I'm going to find the distance formula, or the length. So how do I find length AB? That's going to give me the square root of x2 minus x1 squared plus y2 minus y1 squared. So since I'm going to use A and B, now what is my x2? So x2 is 7. X2 is 7 here, minus x1, which is 3 squared, plus y2. Y2 is 2, minus y1, 5, all squared. So this will give me 7 minus 3 is 4 squared, plus 2 minus 5 will give me -3 squared. So 4 squared will give me 16, -3 squared will give me 9. So this one will give me 16 plus 9 will give me what? 25. So the square root of 25 has given me 5 units, or 5. This is the AB, has given me 5. Now let's go to the BC. The length of BC, the same formula, x2 x1 squared y2. So I'm going to find the length of AC. So the A is 3, 5. Then the C is 3, -1. So now x1 3, y1 5, x2 3, y2 -1. So let's find the length of AC using the formula x2 x1 y2 y1 all squared. Now my x2 is 3, x1 is also 3, all squared, plus y2 -1 y1 minus 5 squared. So 3 minus 3, 0 squared, -1 minus 5, -6 squared. So this one give me 0 plus -6 squared will give me 36. So this will give me 36, which will also give me 6 units. This has given me 5 units. This has given me 6 units. Now let's talk about A, B. So B, C, B, 7, 2, then C, 3 negative 1. So x1 is 7, x2, sorry, x1 is 7, x2 is 3, then y1 is 2, so y1 is 2, and y2 is negative 1. So let's find the length of BC, which will be this. The formula is x2 x1 squared y2 minus y1 squared. Now what is x2 here? x2 is 3 minus x1 7 squared plus y2 negative 1 minus y1 2 squared. So 3 minus 7 negative 4 squared. This one give us negative 3 squared. So this will give us 16 plus 9, which will give us 25, which will give us 5 units. Now what do you see here? We got 5 units here. We got 6 units here. And we've gotten 5 units here. So this is telling us that 2 of the sides of this triangle are the same, or they are equal. So what type of triangle has 2 sides being equal? Is an isosceles triangle. It's an isosceles triangle. So your answer will determine the type of triangle. So therefore, line AB is equal to line BC, which is not equal to line AC. So this is equal to this, but these are not equal to this. So therefore, the triangle is an isosceles. Therefore, the triangle is an isosceles. So assuming we got all the 3 sides being equal, then you should know it is going to be equilateral triangle. So this is how we determine the type of triangle using the distance formula or using the length formula in the coordinate geometry. Let's take the next question on this. We are going to understand more. So the next question, the triangle PQR has vertices P, negative 3, 4, Q 3, 4, and R 0, 9. Show that triangle PQR is no other triangle than equilateral. Now I'll explain this question. So P is negative 3, 4, Q is 3, 4, and R is 09. And they say we should show that it is not any other triangle than equilateral. So it means no matter what happens, you should get an equilateral triangle for this calculation. And this, what the trick in this question is that there are some questions, the answers that you are going to get, you have to approximate the answers in order for you to make the sizes the same. So it is not mandatory or it's not compulsory that you get exactly the same answers, but we will approximate some of the figures. They will be closer. So it's like if you have 6 and get 6.1, it is closer. So now let's see what I'm talking about. So this one to means that we can join the PQ, we can join the PR, then we can join the QR. Yes. So these are the pairs we can get. So first of all, let's find the P, negative 3, or the Q, which is 3, 4. And with this, we know that x1, y1 is 4, x2 is 3, y2 is 4. So let's find the length of P2. X2, then y2 minus y1 squared. So what is our x2 here? x2 is 3 minus x1. It has negative. Then plus y2, 4 minus 4 squared. So follow closely and let's arrive at the right answer. So this one will give us 3 plus 3, negative, negative. Then let me repeat this one, so square. 4 minus 4 squared. So this one will give us 6 squared, then 0 squared. So this one will give me 36 plus 0. So this one has given me 36. So the square root of 36 is 6. This is the first one. So the first one has given me 6 units. The first one has given me 6 units. So follow closely and let's do the other one as well. So 36 units. So let's pair the next one, which is the PR. PR. So P is negative 3, 4. Then R is 0, 9. So with this one, let me even draw a line here. So with this one, our x1 negative 3, y1 is 4, x2 is 0, y2 is 9. So the length of PR, so x2 minus x1 squared plus y2 minus y1 squared. So x2 is 0, x1 negative 3, then plus y2 9 minus y1, which is 4 squared. So here we have 0 plus 3 squared plus 9 minus 4 squared. So this will give me 3 squared plus 5 squared. So we have 9 plus 25. 9 plus 25. So now follow closely. We have our 9 plus 25, which will give me 34. This is what I was talking about. 34 is not a perfect square. 34 is not a perfect square. So since this is not a perfect square, and the question says we should show that it's not any other triangle than equilateral. But when you find the square root of this, you will get 5.8309. Yes. So since we are looking for something equivalent to this, and the 8 here is a roundable number, we are going to approximate the figures. So this one to the nearest whole number. So we round the 8 to the 5, making it what? Also 6 units. So this is a trick in this question. Show that it is not any other triangle than equilateral. So we have to make sure we get the same size, or yes, we make sure that the triangle become the same size. So we didn't get perfect square. We find the square root of it, then you approximate it to the nearest whole number. And when you approximate it, I've taught runnable numbers. So let's see the next answer or the next coordinate as well. The answer. So the next one is QR. QR. So the Q is 34 and R is 09. So my X1, Y1 is 4. X2, 0. Y2 is 9. So now we are going to find the length of QR. Our formula X2, X1 squared, Y2 minus Y1 squared. We follow closely. Our X2 is 0 minus X1 3 plus Y2 9 minus Y1. So 0 minus 3 gives us negative 3 squared. 9 minus 4 also gives us 5 squared. So pay attention. So negative 3 squared we know will give us 9 plus 5 squared which will give us 25. So if it gives us 25, 9 plus 25 also giving us 34, for which when we find the square root we're also going to get the same 5, 8, 30.9, for which we are going to approximate it to 6 units. So we have approximated this figure to 6 units as well. So we got only a perfect square here, but here is closer to the 6. Yes. So therefore, we can say the length EQ is equal to length UR, which is also equal to PR. Yes. For which they are all equal to 6 units. So triangle PUR is an equilateral triangle, or you can say is an equilateral. So this is how we prove, yes, or to determine the type of triangle using the distance formula. So you take your time closely, then you solve it step by step. When you find yourself in a question like this, here's how you do it. Take the next question. It says, what type of triangle is UVW with vertices U, negative 2, 2, V, 3, 2, and W, negative 4, 5. This one, they didn't give us any clue. It's like the first question we solved. They said, what type of triangle? And we can only determine that using our distance formula. Then the answers are going to give us a clue of the type of triangle we are working with. So now we have the triangle, the vertices, we have the U as negative 2, 2. We have the V as 3, 2. Then we have the W, this was negative 4, 5. So you have to know the pair of coordinates we are going to, so we can get our UV, then we can get our UW, then we can get our VW here. So let's find the UV. So the length of UV. So let's find our U. The U is negative 2, 2. Then our V is 3, 2. So let's find the x1, negative 2, y1 is 2. x2 is 3, y2 is 2. So the formula, the length of UV is square root x2 minus x1 squared, y2 minus y1 squared. So you follow closely. So now what is our x2? Now our x2 is 3 minus our x1, negative 2 squared. Yes, negative 2 squared plus y2 is 2 minus y1 is also 2 squared. So we have 3 positive, negative, negative and positive squared. 2 minus 2 squared. I'm repeating it. Then this one will give us 5 squared plus 0 squared. So this one will give us 25 plus 0. Yes, 25 plus 0, for which this one is going to give us the square root of 25, for which it is going to give us 5 units. This has given us 5 units. That's for the first pair, the first 2 coordinates. Now let's take the next one and see which is the U, W. And U is negative 2, 2. W is negative 4, 5. So our x1 is negative 2. So we are going to find the length of UV, listed the x1, x2. The x1 is negative 2, x2 is 2. Then y2, x1 is negative 2, x2 is negative 4, y1 is 2. Then y2 is 5. So let's find the length. So we have x2, negative 4 minus x1, negative 2 squared, plus y2 minus y1, which is 2 squared. So this one will give us negative 4 plus 2 squared, then the 5 minus 2 squared 2. So this one, negative 4 plus 2 will give us negative 2 squared plus 3 squared. So this one will give us 4 plus 9. So 4 plus 9 will give us 13. Yes, 13, for which the square root of 13 will give us 3.6055. So in one decimal place, I can leave it at 3.6, or I can approximate it to 4 units. Yes, this is the second answer. Now let's look at the third one. The third, which is the VW. The VW, for which the V is 3, 2, and the W is negative 4, 5. So x1, 3, y1, 2, x2 negative 4, y2 is 5. So we should determine the type of triangle. So the length of VW, the formula x2 minus x1 squared, y2 minus y1 squared. So what is x2? x2 is negative 4 minus x1, 3 squared, plus y2 5 minus y1 2 squared. So negative 4 minus 3 will give us negative 7 squared plus 3 squared here. So negative 7 squared will give us 49 plus 9. 49 plus 9. Yes. So we've gotten 49 plus 9, for which will give us the square root of 58. For which, when we find the square root of 58, it's going to give us 7.61577, for which I can approximate the answer to 8 units. So I got 5 units here, 4 units here, 8 units. What does it tell us? It tells us that none of the sizes are the same. And a triangle with different sizes is what type of triangle? That is what? A scalene triangle. So you can say line UV is not equal to UW, which is also not equal to VW. So therefore, triangle UVW is a scalene triangle. Yes, you can conclude by saying it's a scalene triangle. So you know the triangle sizes by their name. Yes. But if you do all this and you don't write the correct name of the triangle, you're not going to get your full mark for that. So this is how we prove this one to using the distance formula. So we are going to take our very last question on this segment. So our very last question says determine whether the point negative 81, negative 29, and 10, 0 form the vertices of a right angle or the right triangle. And we know a right triangle, a triangle with one side being equal to 90 degrees. So we should determine if the vertices form a right angle. And this one, how do we determine that? So after using the distance formula, you apply the Pythagoras theory to see. So if I've drawn this right angle triangle and I'm showing the 90 degree sign here, we know this is the hypotenuse. Yes, this is the hypotenuse. This side is opposite and this side is adjacent. I've treated Pythagoras so you can check it out and you understand it more. Now, according to Pythagoras, the square of AB plus the square of AC should give you the square of the square of AB plus the square of BC should give you the square of what? AC. So after we are done getting our point, we are going to determine that. So if we square here and we add it to here and we get this, it means they form the vertices of a right triangle. If we don't get, we conclude by saying the point or the vertices does not form what? Or it doesn't form, the vertices doesn't form a right triangle. Yes, so basically that's the meaning of that. That's the meaning of how we are going to determine. Like the different one is how they say we should show whether one triangle is not any other triangle than a right equilateral. So the points are negative 8, 1, Negative 8, 1, negative 2, 9. Then we have 10, 0. We have 10, 0. So let me use alphabet for them, A, B, and C. So I'll say A is negative 8, 1, B negative 2, 9, then C 10, 0. 10, 0. So I can pair AB, AC, and BC and use it to determine my length. So vertex A negative 8, 1, then B is negative 2, 9, and with this x1 is negative 8, y1 is 1, then x2 negative 2, then y2 is 9. So let's find the length of AB. X2 minus x1 x1 squared, x2 minus x1 squared, y2 minus y1 squared. Okay, so now we have our x2 negative 2 minus x1, so plus our y2 9 minus y1 1 squared. So follow closely here. So this one I'll get negative 2 plus 8 squared plus 9 minus 1 squared. Yes, 9 minus 1 squared. So this one will give us 6 squared plus 8 squared. So this will give us 36 plus 64. 36 plus 64, which will give us 100. Yes, this is going to give us 100. So this has given us 100. Now this one, we don't find the square root of the number. We don't find the square root of the number. There's a reason for that, and I'm going to prove that at the end of the video. So follow closely. So this is the length of AB. Let's find the length of AC. So AC, our A is negative 8, 1. Then our C is 10, 0. X1 is negative. Our X2 is 10. Y2 is 0. So X1, Y1, X2, Y2. Now let's find the length. So X2 minus X1 squared minus Y2 minus Y1 squared. Now X2 is 10 minus X1. So Y2 is 0 minus Y1. So we have 10 plus 8 plus 0 minus 1 will give us negative 1, also squared. So 10 plus 8 will give us 18 squared plus negative 1 squared. So now let's find 18 squared, which is 324 plus 1 squared, which will give us 1. So this one will give us the square root of 325 here. So this one too has given us 325. This one we maintain them in their square root. So there's a reason for that. So let's come to the BC. With the length of BC, and our B is negative 29. Our C is 10, 0. So x1 is negative 2, y1 is 9, x2 is 10, and y2 is 0. Now let's find the length of BC. x2 minus x1 squared, y2 minus y1 squared. So x2, 10, x1, negative 2 squared. Then y2 is 0 minus y1 squared, 9. So this one will give us 10 plus 2 squared, then 0 minus 9 squared. So 10 plus, this one give us 12 squared plus negative 9 squared. So this side will give us 144 plus 81. So 144 plus 81, which will give us the square root of 225. The square root of 225. Now we've gotten 3 points here. And as I indicated earlier, if I have a right angle triangle, like this is the hypotenuse, that's the longest side. And according to Pythagoras, this side square, the two short side square to give you the addition of the two short side square to give you the longer side square. So when you look at it, the biggest value here is the 325. So now let's see. So this side, so the square root of the 100 square plus square root of the 225 square should give us square root of the 325. Now this square will take this square root. We have 100 plus this will also take this. We have 225. Now when we add the 100 to 225, we get 325. Yes. So the square of this plus the square of this, we have gotten this one. Yes, so this makes it a right triangle. So therefore, we can say triangle or the vertices. The vertices I use A, B, C form right triangle. Yeah, so this is the reason why we don't find the square root of the numbers. So when they say prove whether a given triangle is a right triangle, this is how we solve it. So assuming when we squared it, we didn't get the answer equal to the longer side, it means it is not a right triangle. Yes, it means it is not a right triangle. So this brings us to the end of the lesson application triangles or determining if given vertices form a particular type of triangle. And this is further mathematics. So if today is your first time seeing us, don't forget to subscribe and recommend to all students at all levels that the best math channel is on YouTube. So they should come and have a look at it and also benefit from it. Until we meet again, say goodbye for now and wait for another interesting lesson under coordinate geometry. This is a Busy Made It Easy channel, the only channel exam fear and the best math channel in the world. Until we meet again, say goodbye for now.